Hi guys, we're back today to take a look at how we can convert decimal numbers to binary numbers in Excel. There is a function built into Excel that does this for you called des to bin, as you see here in the formula bar. It will convert positive and negative numbers from negative 512 to positive 511. So basically it's a signed 10-bit two's complement binary number is all you can carry out that function for. That's not that useful in most of programming world and I'm sure different disciplines as well. So I made a formula years back or a VBA allow us to convert larger numbers. And I've got two tables set up here on the screen. You'll see the built-in one that does a positive 2 to the ninth or a signed 10-bit 2 to the ninth, so we can go to negative 512. And you see what happens as soon as you go positive above 511. You get this error, this pound number, to let you know, hey, Excel's function cannot handle that. And before you reach that, one number less, 511, you'll see that you've got 9 ones all in a row. And a positive number, incrementing after that, there's no reason it can't continue beyond that. I'm not sure why Excel limited theirs to this 9-bit positive. But all it would be is adding another 1 to the front and changing all of these 1s to 0. My function does that all the way up to a 32-bit signed 2's complement binary number. And I've just shown what the same positive 512 and positive 511 look like with my function, and it shows their length of 31 here. So if we go to negative 512, it will look the same as a negative 512 here in Excel's built-in function, except these ones here over are masked off and not shown or not calculated in the first place. So we're getting the same values, except mine lets us go up to 2 to the 31st. So that is 2 to the 31st. Can't go that high, right? We're actually only going to be able to go negative 2 to the 31st. And that's what that looks like. That takes 32 bits to accomplish that. If we do this same value and we just say, let's subtract 1 from it, you'll see what the positive limit is. 32-bit signed 2's complement binary number. Pretty straightforward, quick, and allows you to carry out more common functions that you may want to plan out in Excel, being able to have 32 bits to do so versus 10. So if we take a look at the VBA code to accomplish this, it's not that much. It's really got two sections. One that handles positive numbers, this is this bottom section, and one that handles the top, or the negative numbers. So when you pass in your decimal number, I pass it in as a variant. You don't necessarily have to. But the first thing we do here is we check to see if the number or the value passed in is actually a number. If it's not, we're going to exit the function and call it an error. We'll do the same one, the pound num exclamation mark. Okay, but if it is numeric, and we come in and we see that it's less than 0, we're going to convert it here back to a positive number, adding 1. And we have to do that the way I've got this set up because I've got the same loop iterating over, or the exact same functions iterating over the loop if it's negative or positive, except I place a 1 or a 0 in the place as I build the string. So what we do, let's just start with the positive number instead. If the number is greater than or equal to 1, we're going to do a mod 2, which is kind of our limit. This function, once you have a value that's positive 2 to the 32nd or greater, this function will fail. So maybe that's a way to extend it further. If you wanted, you could make a mod instruction of your own or a mod function that would allow you to actually handle a mod greater than a positive number. So if it's equal to 1, we're going to put the number 1 at the beginning of our string that we're going to develop for our binary representation. Then we will subtract 1 off, divide by 2, We'll loop back around and do it again. We'll keep doing this. We're going to keep moving through. If it's an even number, we'll put a 0, divide by 2, and move back to the front, or back to the top of the loop until we get all the way through the loop. And you're going to see this just build our number over time through this loop. And then once we get done, if it's a positive number less than the maximum represented with a 31-bit positive, then we're going to fill that front area with zeros. And that's what this does here. We just decide how many bits are left that need to be zeros, and then we're just going to tack them onto the front in this loop. We do the same thing up here for the negatives, except we put an opposite bit in place of where those are, and that's a function of the 2's complement. You can learn more about what that representation actually means and how they work, but essentially once you get to 511, you have all ones. Let's try that. Once we go to 512, it's going to flip it's going to leave the sign bit and flip all of these back to 0. So the counting in binary changes for a 2's complement once you go past once you go from positive to negative. It's kind of an inverse. So if we say negative 512, and remember we're going from all ones there, we go to negative 512, all of those flip to zeros, and the 1 at the front signifies a negative number. Go a little bit more negative, 511, you see how we start to count up. It's like you take the max and you start subtracting off that binary amount. There's some negative 510. Now we're going to have a negative maximum of 10 bits, and then subtract off 2. Same if you go to 509, now we'll subtract off 3. So my function does that in a different way. This is one way you could do it. Just do 2 to the 9th minus whatever the difference is between negative 512 and whatever number you're going to, and then turn that back into a positive representation here. That's all this is, negative. So subtract 3 off of your maximum negative number. Same thing is going on here, except we can represent it with, or all the way to 31 bits. So if you have any questions, or you'd like to have this function, I'll show the code one more time. I'll do a slow scroll through. Here's the function. Any issues, we're going to go to E and error out. Pause the video while I'm just showing you this here, but it's not that much. Very easy math, and beats going to a website to type in the numbers, especially if you've got 100 or who knows how many numbers to convert from decimal to binary. Anyway, let me know if you have any questions. I'm happy to answer them, or build a function a little bit differently. You'd like to see it. If processing time is not a concern of yours, this is an easy function to copy and paste in. We can make it much more efficient and shave some microseconds off. So anyway, thanks for watching, and let me know if you have any questions.